Okay, so good afternoon, everyone. Okay, so this lesson is to go through your EYE paper. We will start with paper 2 first. Okay, paper 2, we have already gone through most of the questions. And in fact, I've uploaded the answers for most of the questions as well. So let's not spend today just copying down the answers. That's not the best way to spend time today. The best way to spend time today is to learn what skills are needed and what trends are there in the pure chemistry O-level papers. Now, if you were to just look at 10-year series, if you look at the progression of the papers, you would have realized by now that O-level pure chemistry is very different from combined science because the questions are almost always data-based. Even though there's only one question that's data-based in theory, actually every single question requires you to interpret a diagram, a table of data, or even a picture, a graph. Okay, and this is typical for Pure Chem. So this is exactly what happened this year during the O-level Pure Chem paper. Okay, where many people said that, wow, it was tough, there was a lot to write and read, and that's the idea. And this is the reason why it is even more important for me as the setter to ensure that you are well prepared with these skills to analyze a question. So I want you to focus on this. As we are going through, learn how I dissect and break down a question. Learn which keywords I pay attention to. Don't just copy down blindly. All right? So now, we have already gone through everything until A7, I believe. So I will not go through the same question. Let's go straight to the A8. Now, A8, as you can see, is another question that requires relatively a lot of data analysis. Firstly, you have an introduction, which you need to read. Then you have a table of values to look at. Now, the first thing to do is always to highlight or underline the keywords. It is important to underline keywords like acid. That's a chemical name, right? The next thing to underline is always mathematical trends. This is an important trend to underline or highlight. If you didn't underline or highlight this trend, you wouldn't know what Ka means, right? Because you have never learned Ka before. But now that you have been told a larger Ka value indicates a greater extent of dissociation into ions. Now, this you have learned before. Dissociation into ions is what acids do, right? The acid dissolves in water to produce H+ ions. If there's a greater extent, it means that it's stronger acid. Greater extent of dissociation means it's a stronger acid, which means that larger Ka equals stronger acid. These are the notes you need to make during an exam if you want to succeed in this kind of question. Okay? So underline the chemical names and underline mathematical trends like these. Then you move on to the table. You realize that there are values for Ka given to you. You notice that the values for Ka are increasing. They go from 10 to the power minus 4 to 10 to the power 6, 10 to the power 9, 10 to the power 9 as well. Ka increases. And what did we just say about larger Ka? Stronger acid, right? So these are, again, the annotations that you need to make in an exam. Next, you realize that this is about group 7 elements. They all contain the group 7 elements, meaning as I move down group 7, the Ka increases. As I move down group 7, the acids they form become stronger. And then we move on to tell you that one of the factors affecting the strength of acid is the strength of the covalent bonds present. At this stage, you should start thinking, the covalent bonds are these. These are the covalent bonds, right? And it's also repeated in table 8.2. These are the covalent bonds. Now, the strength of the covalent bond is expressed by bond energy. And this is again a mathematical trend. Higher bond energy, stronger covalent bond. So look at group 7 now. As you go down the group, the bond energy decreases, meaning it's a weaker covalent bond. So now let's link the two together. Stronger acid, weaker bond. Right? So this is called making links. Now, you will realize that you will not be able to make the link if you just didn't write it out. Okay? So for your database questions, you have to write this kind of notes out. If you don't even do this, you are not making sense of the data. Okay? So this is about breaking down data, identifying mathematical trends and patterns, then relating trends and patterns together. 3 skills. Okay, so define what is meant by strong acid. I think this is easy. This one I shall not harp on it. You can look at it later in the contents library. More importantly, you'll realize the next page is exactly what I just said. If you just go down group 7, the acid strength increases. And the main reason can be seen by the increasing Ka value. Then they ask you to suggest an explanation. Of course, it's because the covalent bond becomes weaker down group 7. So you need less energy to overcome the covalent bond to cause dissociation into H+ ions. Okay? So you can see it's all about relating data to observations. To do this, you must need to know what the data means. What is Ka? What is bond energy? Again, these are things you don't learn as part of the syllabus. You don't just memorize it. You need to take the information given to you, break it down. That's what we just did. Okay? Can? Now, part C, put a star. Now, part C is in syllabus, but actually it has not been tested for so many years. Water is neutral. All of us know that. Even as Sec 2 students, you learn this in Sec 2. Pure water has a pH of 7. It's neutral. But why? So what makes something neutral? What makes something neutral is this equation. Water produces both H+ and OH- when it dissociates into ions. So the concentration of H+ is equal to the concentration of OH- ions. When both H+ and OH- are equal in concentration, the substance is neutral. This is the definition of neutral. Okay, so I hope you know this by now. Now, this has not been tested for a number of years, but you need to be familiar with this because this is actually part of the syllabus. Okay? So what makes something acidic? Something is acidic because the concentration of H+ is higher than the concentration of OH-. Something is alkaline because the concentration of OH- ions is higher than the concentration of H+. So it's always relative. Which ion is higher in concentration? Okay? Now that concludes A8, which I admit is not easy, but yes, this has occurred in the O-level syllabus before. Okay, so this Ka question has appeared before. Now moving on, let's go to the real monster in the house, which is the next one. Now, models in chemistry. This is an entire page to read. Now, if you thought this was bad, well, the O-levels could actually give you 2 pages of info to read. So this is a 1-page information sheet that you must read. Now, you have actually learned models in lower sec. When you learn science in lower sec, right, we taught you model of cells, model of lights, model of the atom, which is what is done here. So models are used to represent abstract concepts like atoms, right? Models allow you to predict behavior, properties. But the most important thing when you see a database is to read it quickly and see what's important. What's important is always chemical names, mathematical trends, and numbers. All right? So the concept of an atom is the most basic unit of matter. This is a mathematical trend, right? Atoms are the most basic. It's like the building block, okay? Then you go into the table one by one. Now, a good hint where it's important is always to look at the bullet points. If we give you bullet points, that tells you that these are important pieces of information. Okay? So you read the information and you think, is it correct? What does it mean? Okay? So next, besides bullet points, when we give you like diagrams, you need to see what's the difference between the diagram. These are three models, each look different. What is the similarity? What's the difference? Definitely, we will ask you, right? Which model is similar and how is it similar? Then you take your pencil lah, huh? Similar, use one color, right? Similar. Electrons are both present in the J.J. Thomson plum pudding model as well as the Rutherford planetary model. These are the similarities. The differences, use another color. You have a spherical cloud of positive charge, whereas in the Rutherford model, the positive charge is in the center of the atom. Right, different, right? Spherical cloud versus center, it's different things. Okay? So obviously, that's the first question. State one similarity and difference. There are many, I've just chosen some. So the similarity has to do with electrons, right? Electrons are negatively charged, or electrons are moving around in the atom. That's a similarity in both models. The difference, though, is that, like I mentioned, the Thomson model states that the positive charge is in the spherical cloud, whereas the Rutherford model states that the positive protons are found in the center of the atom. Okay? So this is recognizing patterns. Patterns. So whenever we have questions that ask you about similarity and differences, it's about recognizing patterns. It's almost like when you were a kid, how do you do those questions that ask you to identify the difference? You look at both, see what is the same, see what is different. That's called a pattern. All right. Next, Rutherford claimed that the mass of an atom is concentrated in the center. Wow, this sentence sounds familiar, right? What is the center of the atom called? The center of the atom you have studied is called the nucleus. Then you got to think now, okay, I studied the nucleus in the lesson. How can I use my contextual knowledge to link to the answer? So nucleus contains what? Nucleus contains protons and neutrons. Right? Nucleus contains proton and neutron. Proton and neutron have a relative mass of 1. And that's the answer, right? You just needed to say that the protons and neutrons are found in the nucleus and both have a relative mass of 1. And that gives you the answer. Okay? Next. Now, part C. Part C is the difficult one, where you need to evaluate. Evaluate means you need to tell me, is it right or wrong? And it means you need to give me evidence. This is the highest level of database, where you need to tell me right or wrong, true or untrue, and give me evidence to support your answer. So obviously, John Dalton claimed that all atoms of the same element have the same mass and physical properties. I'm sure you know by now this is not true, right? Why is it not true? Because you have learned that there are atoms of the same element with different number of neutrons, isotopes, right? So this question is asking you about isotopes. Obviously, isotopes having different number of neutrons will ultimately have different mass and also different physical properties like different melting point, different densities, all right? Now, you realize the answer is not long. The answer we expect is rarely very long. But the idea is getting to this concept, okay? Now, this is one tip I have for you. Always look at the words. Think of these words. Where do you last see these words? Have you learned this phrase before? Atoms of the same element. Well, you did. Atoms of the same element is the phrase that appears when you learn the definition of isotopes. So in an exam, it is very important to link to what you had learned before. Okay? Don't panic just because a question looks unfamiliar. Okay? Now, if you really forgot everything, then you should at least know that, oh, this is atomic structure. Let me go through my brain, see what I remember from atomic structure. Atomic structure, I learned atom. I learned proton, electron, neutron. I learned isotope. So which keyword is important here? Okay? This is what you need in an exam. Okay? So this is how you do a database question that requires you to predict, see patterns, evaluate. Okay? Now the next one. Now the next question is the 2020 Pure Chem O-level question, where they gave these diagrams, which are models, and asked the students how come the models are not accurate representations of the molecule. There are so many reasons. There are so many. All right? But it all comes down to the fact that the models don't show the radius of the atom to scale. They don't show the length of the bonds to scale. Okay, moreover, the dot and cross diagram is a flat two-dimensional representation. Molecules are not flat. Molecules are three-dimensional. You know that because we are made of molecules, right? You don't see yourself being a 2D flat paper, okay? So there are so many reasons which I will not label the point now. More importantly, how do you do such questions? Because the same question may not come out again, but the skill may come out again. To tell whether something is accurate or not, use the data. Obviously, I must make use of this in my answer, right? The length of the bond. If the length of the bond is not in your answer, then what's the point of giving it to you? Next, the atomic radius of the atom, must be the answer. So it must have something to do with whether the length is correctly shown, whether the radius is correctly shown, whether it's to scale. Okay? Now, if you think that this is very challenging, well, it's challenging if you don't think through the data. That's why it's important to use the data as clues to help anchor your answers. Right? Okay? So this is how you do this question, and this question came from 2020 O-level Pure Chem, paper 2. Now moving on. Now the next question, okay, proving Mendeleev's periodic table. Again, it's a long passage to read. All right. Whenever you have a long passage, again, go for the chemical names. Okay. Besides the chemical names, go for the mathematical trends. Dmitry Mendeleev is not a chemical trend, it's not a mathematical trend. But what is a chemical trend is this. Actually, it came down to this sentence, right? The moment you realize that Ecca aluminium, whatever this is, it must be similar to aluminium. Then you must think, okay, aluminium is from group 3. What do I know about aluminium? Aluminium, 3 valence electrons. Right? If I know 3 valence electrons means it will lose 3 valence electrons. So it will be 3 plus charge. Besides that, aluminium, what else do I know about aluminium? Amphoteric oxide. Aluminium forms amphoteric oxides. Aluminium is a metal. And so on. So the idea is, once you latch on to that important sentence, you really go and fan out in your brain to think through what have you learned about aluminium in class. So again, using information relating to what you have learned. And that will give you all the answers that you need. Actually, looking back, is this table really so difficult to fill in? Maybe not. The idea is finding the right sentence, which is what I've highlighted, and fanning out in your brain what you already know. Okay? So, in short, please ensure you underline keywords like chemical names, mathematical trends and numbers, so that you really home in on the right thing to analyze. Don't highlight the whole passage because obviously that's not helping you. Okay? Now, even though you don't highlight the passage, you must still read the passage. This is very important. The database will not be set on something that you would have done before extensively in class. Of course, with practice, you will be exposed to more things. But trust me, there's so many things we can test you on for database. The way to do well for database is to maintain curiosity and read up more. That's why I send you articles to read. It's not for fun. You're supposed to read it. Number 2, as you read, you must know what are the important concepts to highlight, to think through. Okay? Now, this is typical. So this year's O-level Pure Chem involved 2 pages of information to read. And actually, there were a few parts that students have never learned before, but actually the answers are in the passage. They just needed to read the correct sentence and extract it for the answer. Okay? So this is a skill. All right, moving on. Now the next question. The next question is obviously an essay question. I told you there's one question like this in section B as well. After the database, the question is usually a question that involves recall of information. All right. So this is about recalling information, bonding and structure in diamond and graphite. It's something that you would have learned before extensively, so you should score 8 out of 8. If you didn't score 8 out of 8 for B10, it means that you need to revise more thoroughly, particularly diamond and graphite. Okay? Now, I'm not going to belabor the point. Later on, you can also go back to the OneNote to take these answers down. But as you can see, it is a good 4 marks. So being able to do this well is important. Okay? Just to let you know, something similar to this came out this year for O-level Pure Chem as well. Okay, so whatever I've trained you, the skills are totally relevant. So if I tell you that you must be prepared to write an essay that's content-based like this, you need to work on it. So this is the similarity and differences between diamond and graphite in terms of their bonding and structures. Moving on. Part B, the difference in hardness of diamond and graphite. Again, you can study for this, right? Diamond is one of the hardest materials, whereas graphite is very easily scratched because the bonds inside are different. Okay, diamond is hard because the strong covalent bonds between carbon atoms require a lot of energy to overcome. Whereas for graphite, it has weak intermolecular forces of attraction between the layers, which require little energy to overcome. Okay, so it's all about the kinds of forces of attraction that you overcome. Now, can we please take note? Don't use terms wrongly. Covalent bonds must be between atoms. They share electrons between atoms. For graphite, the weak intermolecular forces are between the layers. Okay, so once you use the term wrongly, then obviously the explanation will not be correct as well. So what terms do you need to know very well? You need to know terms like atoms, molecules, and ions very well. They are not the same. They each have a different meaning, and so you should be disciplined to use the terms correctly in the right context. Okay, this is why studying bonding is important. If you are unclear about these three words, go back and study chapter 6 and 7. Finally, the next one. Graphite reacts with fluorine gas to form gaseous carbon tetrafluoride. Carbon tetrafluoride is a keyword. It's gaseous. Gaseous means low boiling point. The boiling point must be low such that it exists as a gas, which immediately tells you that this molecule mustn't be giant molecular. This molecule, carbon tetrafluoride, CF4, must be simple molecular. So there are weak intermolecular forces of attraction between the CF4 molecules, which require little energy to overcome, hence the boiling point is low. So you can see that it's all about bonding, this question. Okay, and it really, the success lies on you understanding the content well. Okay, so with this, we have finished B10 as well. This is really an essay-like question involving more content recall than other questions. There is always a question like this in the O-level paper, so you are advised to really understand the content very, very well. Okay, at this juncture, let me just pause for a while. Do we have any specific questions regarding the database as well as this question, which is more essay-based? You may unmute to ask, or you could type in the chat to me. I can see it. No? Calling for any questions? Okay, if not, I'm going to move on. Okay, from here. Now we go to the option question. Now, many students always ask me, okay, not just pure chem students, combined science students also, how do I choose the questions? Do I spot topics? Is it true that the either question must be this topic, the or question must be a different topic? No. So what happened this year for pure chem as well was that the either and or question were both of the same chapter, which means that students didn't really get a choice of chapters. Both questions were on the same chapter. All right. So let's not spot topics. Spotting topics is actually a very poor strategy in studying. It is not possible to spot. You can rest assured that all the chapters you have learned will be tested in some way. All right. Now, how do you actually choose questions? What I would always encourage students to do is to flip quickly. Even without me saying, you know that this is chromatography, right? So that means either must be chromatography. Even without me saying, this is some titration mole concept thing, right? So now you're going to ask yourself, if your chromatography and titration are not so good, would you want to do this question? The next question, the or question, it's on pollution. Also got a little bit of more concept, followed by these two graphs, which you definitely need to use in your 4-mark answer. So yes, the all question is on atmosphere, but more importantly, you need to realize that it involves graphical analysis. So now you can ask yourself, if you don't even understand the graphs, would you choose this question? So between the two, yes, either has more small parts, but maybe the small parts are things that you know how to do. Okay, so that's how you make the decision. You have to see which question of the two you're more confident of answering. Next, do we do both questions? Please don't. From experience, students who attempt both questions end up not doing very well because they don't have enough time to pay attention to just one question. It's better to focus on one question, stick with it. Okay? And that's the reason why it's important to think through first before you start doing, because you really want to stick to your decision and not change halfway. So either, again, chemical names, iron 2-sulfate, iron ions, iron tablets. So the whole idea is Fe2 plus is the key. Many of you later on in the more concept didn't realize that Fe2 plus is in Fe2 sulfate, iron 2 sulfate. So one method to check the purity is to use chromatography. I'm sure you know that. And this is where you all fell for the first trick. The starting line is not at 0. We mentioned this before, right? If the starting line is not at 0, this means that the distance traveled is not 11. The distance traveled is 11 minus 1, 10. So if we didn't even realize this first trick, you would have gotten the RF value wrong. Okay? Next. So obviously it starts off by saying, oh, why must the start line be drawn in pencil? I'm sure you know this by now. It's because pencil lead doesn't dissolve in water. Because pencil lead doesn't dissolve in water, it will not create additional spots that will move up the chromatogram. Okay, next. This one I'm sure you also know by now. The RF value, you must minus 1 because the starting line is at 1. Okay, so the answer is 0.2. Common trick. WA1, you got tricked once already. End of your exam, you get tricked another time. Hopefully, this will be the last time you get tricked like this. Now, however, it is not this question that's the hardest. Part 3 is the hardest. Why? Because many of you could give conclusions, but you couldn't describe and explain evidence. Evidence means you need to go back to the chromatogram itself, look at what parts of the chromatogram support your conclusion. For example, many of you could say that, oh, the tablet is impure. Yes, I know that. But how do you give me evidence? Impure is a conclusion. The evidence comes from, as seen by the 2 spots above Fe2 plus, right? Telling me that there are 2 spots on top of Fe2 plus and an insoluble component on the start line. So giving me this, what you see from the chromatogram. So this is from the chromatogram. Now this time around for the end of the exam, I was relatively lenient for this part. But for the O levels, you need to realize that when they ask you for evidence, you must give evidence from the diagram, from the graph, from the data. And if you look at the past year trends, for the past 3-4 years, this has been the question. They will always ask you for evidence to support your conclusions. Okay? So similarly, other conclusions you could give me is like, for example, there are 2 components in the iron tablet that have very similar solubilities. How you know that? Oh, because the 2 spots are located very close to each other. That's an evidence, because that's what you see from the chromatogram. Okay? So I hope you realize by now, such questions are common. Giving conclusions, predictions, and giving evidence. Okay? This is a skill that the examiners really want to test Pure Chem students on. You don't usually see this for combined science because this is a skill they want to develop in Pure Chem students. Okay? Now, of course, another way to check purity is titration. I'm sure you know that by now. titration allows you to find the concentration. Many of you could not find the equation, but isn't the equation here? The equation may be located on the previous page. That's a learning point for you to take note as well. Now, the actual titration is not difficult. I think most of you managed to get a start on it, which is good. So your mole concept is not so bad, right? Most of you could get, for example, this part to find number of moles of potassium manganate 7. You took concentration times volume. And virtually everyone remembered to convert volume to dm³. Good. This is not a problem. The problem is many of you for part 3 couldn't find a mole ratio. Well, isn't iron 2 sulfate Fe2 plus in the question, right? So the mole ratio is 1:5. How I know it's 1:5? The equation, the ionic equation is on the previous page. 5 Fe2 plus, 1 MnO4 minus. And so 1:5. Now they want the mass of iron 2 sulfate. What is iron 2 sulfate? Iron 2 sulfate, FeSO4. So you must take the number of moles times the MR. Okay, so it's N times MR, not M. N times MR, which gives you the answer 281.2 milligrams. Now, in hindsight, when you look at it again, how come I never realized the equation was on the previous page? Well, I hope you realize by now, maybe the answers may be from the previous page. So remember to look back. All right. I'm sure once you can get 281.2, finding percentage purity is super simple. And the last part, how do you check purity? That's simple as well. Having said that, can I just make a point? It's an iron tablet. Tablets are solids. So obviously we check melting point. For a solid, we will check the melting point. If it's a liquid medicine like syrup, then you use boiling point. Don't go and boil a solid because obviously to boil a solid, to check its boiling point, takes a lot more heating. So for a tablet, the logical thing to do is to check the melting point. Okay? So with that, I think you will realize that either this question has many small parts, but actually each part is quite easy lah. Right? Then we go to all. The first part is to really tell me the harmful effects of each pollutant. It's not difficult. All right? If you have learned the content, it's not difficult. However, can I just say one thing? For atmosphere and environment, if you don't learn the content now, the problem gets worse and worse because you procrastinate. You leave it to the last minute, you will suddenly realize that Pure Chem has so many things you need to memorize. And that's why we have spread out the teaching. We have deliberately taught atmosphere this year so that you have a bit more time than average students to actually absorb and memorize this content. So you have from now all the way until your O-levels next year to learn this content well. Okay? So as mentioned, carbon monoxide combines with hemoglobin, forms carboxyhemoglobin, and that will reduce the efficiency of oxygen uptake and transport by your red blood cells. Nitrogen monoxide is one of those oxides of nitrogen. It will react with rainwater to form acid rain, which obviously corrodes your limestone buildings and metal structures, lowers the pH of lakes and oceans, leaches nutrients from the soil. Next, okay, writing the chemical equation for the reaction between CO and NO in the catalytic converter. This is something that is under the atmosphere chapter. Now, part 2 is not difficult at all because we know that these are gases. Both N2 and CO are gases. Because they are gases, you can just compare volume. So there's no need to convert to mole if they are both gases. So we last did this under worksheet number 7 in mole concept when we did limiting reactants. All right, there are many questions like these where the both reactants that you're comparing are gases. Therefore, you can just compare their volumes directly. So in this case, N2 to CO is 1:2, so 240 cm³ of nitrogen gas is to 480 cm³ of carbon monoxide. So up to this stage, 5 marks. I wouldn't say these 5 marks are very hard. The really hard one is the next 4 marks. All right. So yes, this question has fewer parts to answer, but it's more challenging because the next part involves graphs. And this is why I want to spend a bit more time. This is like database part 2, right? It's another database question in your paper. And this is realistic. For the O levels, yes, you have one database in section B, but actually you realize that the either-or questions are also based on data. So first, when you have a graph, you must know the the axis, what it means. So it's exhaust temperature with power. Then you must know mathematical trends. 0 kilowatts means car is stationary. Higher power, faster, important. So let's put this on the graph. Faster speed. 0 kilowatts, stationary. Okay? So what do you notice about the temperature? If it's stationary, the temperature is low. If it's faster speed, temperature high. That makes perfect sense, right? If a car has been running at high speed, high power, you touch the car engine hot. If the car is just at the car park, stationary, cold. Okay? Now, to do this kind of graph questions correctly, axis. Pay attention to axis. Write down the trend. Stationary, faster speed. Temperature low, temperature high. This is important because you've got to make sense of it with the next graph. The next graph is percentage yield of what? Percentage yield of the reaction between NO and CO. Oh, so this is the percentage conversion of NO and CO, right? Against the temperature. Oh my God. We just talked about temperature just now, right? So you realize this is not so straightforward. You realize that this graph is not just linear, it's a curve. When you have this kind of bell-shaped curve, you should always look for the maximum points. Somewhere here. So basically the percentage yield or conversion is highest at 500 degrees Celsius. But it's very low at other temperatures like 100 or 700. So now let's look at both graphs. It looks small now because I've zoomed out, but you can see, right? We try to match like stationary 100 watts. 100 watts is here. When it's stationary, 100 watts, 100 degrees, sorry, 0% yield. There is no conversion, no reaction, right? On the other hand, over here, wow, fast, high temperature, about 700. You go and compare again. 20% yield, which is not high, right? We have learned 20% is actually quite low. So what does it tell you? Stationary, 0% yield, bad. High temperature, 20% yield, also bad. And that brings us to the question, right? Isn't that the question? A catalytic converter is not very effective when it's stationary. We just said stationary, 0% yield, bad. Catalytic converter becomes less effective beyond 50 kilowatts because beyond 50 kilowatts when the temperature is very high. So the percentage U also drop to 20%. So look at my answers. What do you notice? My answers are, how do I get 4 marks? 4 marks comes in by telling me low U when the exhaust temperature is low, 1 mark. Then you quote values, 100 degrees, 0 kilowatt, 0%. Quote values. Then the next bullet point, as your operating power is increased, the exhaust temperature will increase. So sharp drop in percentage U. Then give me the numbers. So it's always like that, point, data code, point, data code. That's why it's 4 marks. You might think that Mr. So is a bit cruel in giving you these questions, but it's an important skill. Okay, one of the feedback that many students said from this year's Pure Chem paper is that there were many of these kind of 4 marks questions, which they didn't really know what to write. So remember, when we are giving you 4 marks for database like that, it is always 1 mark for point, 1 mark for the data, evidence, or quote. Since there are 2 points here, you need 2 data quotes. Okay, 10. Now, the very last part is about global warming. So what happens when your CO2 increases non-stop? If your CO2 concentration continues to increase, obviously you have global warming. But let's move on. If there's global warming, what would it cause? Okay, I'm sure you all know by now. Say something like sea level rise, increase in extreme weather events. For example, now in the Philippines, okay, there are some severe typhoons. Typhoons can be made more serious if the seas are warmer. Okay. So with that, we have finished paper 2. Okay, time now is 4:23. I think I have time to go on to paper 1. Okay, so once you're done with this, okay, those on Zoom, can you give me a thumbs up once you're done with this? Then we move to paper 1. Okay, obviously, I'm not going to go through every question, not possible. But let me just go through some of the more problematic ones. Okay, let's go to paper 1. If you are lost and you didn't take everything down, please take note. You can find it under assessments and exams. EOY paper 2 is there. Now let's go to EOY paper 1. Now the worst done questions were all the questions in the middle. Bonding, as well as mole concept. Now, I'm going to just spend a bit of time to go through a few questions. Let's start from question 24, which is what's on my screen. Okay, as you can see, I didn't just give you the answers. I've already written down notes to help explain. Now, question 24 is one of those questions that are difficult, but actually, if you have done the MCQ sets and the theory workbook, you have seen this question in the theory workbook. All right. Now, if you continue to do my MCQ revision sets, you will realize that this question comes out 3 times in the 117 questions. All right. Now, the equation is given. Obviously, this is an equation that you need to look at, in particular the state symbols, right? It's quite obvious that it forms calcium sulfate solid. It's solid. Solid means it's a precipitate. What have you learned about solids? Ionic compounds as a solid doesn't conduct electricity. So as it forms calcium sulfate, it forms a solid, right? Solid, the conductivity should drop. So definitely B is wrong. D is wrong. The conductivity must decrease with time because a solid is formed. So why is it that we choose C instead of A? This is the point where the reaction is complete. That means you have already formed all the calcium sulfate already. So why does it increase? It's because you added excess acid. Now, what have you learned about acid? Acid has H+ ions. So if the acid is in excess, you got more and more ions dissolved in water. So the conductivity goes back up again because you have excess acid added. Acid equals H+ ions, which can move freely in solution to conduct electricity. So the electrical conductivity will go back up as you add excess acid. Okay? Can? So this one you can find it in the theory workbook. You can also find it in my MCQ revision set. This gives you a flavor that, oh, this concept is commonly tested. Okay? Next. Let's go to question 27. 27 is obviously mole concept, right? But exactly what from mole concept? The fact that I've given you numbers tells you that, oh, this is a reaction between magnesium and nitric acid, right? It forms magnesium nitrate and hydrogen. To balance the equation, we put 2 in front of nitric acid. Then you look at the question. I've given you number for magnesium, numbers for nitric acid. Meaning, I have given you quantities of both reactants. Whenever the MCQ gives you quantities of the 2 reactants, reactants means starting materials, right? This is a limiting reactant question. So that's when you know, okay, this is some limiting reactant thing. So the first step is to convert this to moles. You need to convert this to moles in order to do this question. If you do that, you will realize that one of them will be in excess, the other one is limiting. Okay. Just give me a minute. Let me just calculate. 0.96 grams of magnesium. This, if you divide by 24, gives you 0.04 mole of magnesium. 200 cm³ of nitric acid of 0.5 mole per dm³ is 0.1 mole of nitric acid. So now you're going to decide what is the limiting reactant. So you look, magnesium to nitric acid is 1:2. So if magnesium is 0.04 mole, it should require 0.08 mole of nitric acid, right? However, there is 0.1 mole of nitric acid, which is more than the 0.08 moles required. If it's more than what is required, that means nitric acid is in excess. Magnesium is the limiting reactant. All right. And so that gives us 0.04 moles of magnesium. Hydrogen is 1:1 ratio. 0.04 mole is to 0.04 mole. You convert this to volume by multiplying by 24. You get 960 cm³. Okay. Now you realize by now a few things. One, you need to recognize it's a limiting reactant question. Two, you need to realize that mole concept is a potentially time-intensive question. Okay? Mole concept, rarely can you answer the question in 10 seconds because you need to calculate, you need to write things out. So you must be mindful. Mole concept appear in the middle of your paper, right? So you need to be mindful that mole concept, you cannot waste too much time. You need to allow time to do other things later on. All right? So that's question 27. Okay, Ken? Next, question 28. 28 came from the mole concept TYS. All right, we will give you different sulfates. You realize that the mole ratio for all these sulfates, the mole ratio are all the same with oxygen, I believe. Yes, it is a 2:1 ratio for all of them. So if I use 2 grams of the metal sulfate, which one gives me the most oxygen gas? Well, obviously, this has to become number of moles. All right, obviously, this has to do with number of moles. How many moles is 2 grams, right? And that will depend on the MR of the metal sulfate. Because to convert to number of moles, I need to divide by MR. So if the MR is very small, my 2 grams is many moles, big moles. But if the MR is very big, then 2 grams is actually very little moles. So obviously, which one has the smallest MR will give me the biggest number of moles. Smallest MR, magnesium. That's the answer. This is how you do question 28 quickly. Question 29. This was another question that we had gone through in class when we were doing the mole concept TYS, right? Where I told you that if you have unknown elements, Y, okay, you cannot use 5.6 grams to do the answer because I don't know what Y is. If you don't know what Y is, you can never use 5.6 grams in your answer. You don't know Y, but you know oxygen, right? If 10 grams of the oxide contains 5.6 grams of element Y, this means that 4.4 grams is oxygen, right? 10 grams minus 5.6 is equal 4.4. 4.4 grams is due to oxygen. So what do you do next? Mole. 4.4 divided by 16. Why 16? Why not 2 times 16? Because I'm interested in oxygen atom. Atom. O, not O2. O2 is oxygen gas, right? So I only divide by 16. Then what do I do next? So this is oxygen, right? Oxygen is 5 left, but Y only got 2. So I must now do what? Times 2/5 lah. That's the number of moles of Y. So the answer is A. Okay? So that concludes the mole concept portions that I want to go through. Now let's travel backwards a little. And let's go back to question 21. This one is bonding, but it's very hard. I meant it to be tricky in this sense because there are various concepts together. First concept is metal versus non-metal. You need to know that non-metal P is a non-metal. Non-metals must form negative ions. You know that one. Chlorine, Cl minus ion, right? Oxygen, O2 minus ion. So once you know that, A and B is wrong, right? It cannot be A and B because the non-metal P must form negative ion. Next, metal Q must form positive ion. Okay, so now let's look at the next sentence. Obviously, this is the key, right? Each positive ion surrounded by 6 negative ions, but each negative ion only surrounded by 3 positive ions. So what does this mean? Which one is more powerful in attracting stuff? Which one attracts more? The positive ion attracts more negative ions, right? That's why each positive ion surrounded by 6, right? is more attractive. What makes it more attractive or more strongly attractive? Because higher charge. That means the positive ion has a higher charge. The plus must be a bigger charge, which gives us D, right? The plus charge, the positive ion must have a higher charge than the negative ion. Okay, so looking back, I'm sure you realize that, wow, it's quite straightforward, right? But the difficulty here that you faced was you didn't realize there were two concepts. The first concept is about metal versus non-metal. The second concept is about, did you realize that the ratio of ions tells you how attractive an ion is? And how attractive the ion is depends on its charge. Okay? So with that, that's one of the tricky bonding questions. Now, if you have done the 133 MCQs, you would have realized that this is one of the MCQs inside. Okay, but I swapped the elements around. Okay, moving on. If you go back to question 20, how many bonding pairs you need to count? Number of bonds. So you count the lines. Every single line is one pair of bonding electrons. So question 20, if you count carefully, there are 14 bonds. So 14 bonding pairs. Okay, now let's go backwards to question 16. Bromine crystals can be obtained by cooling liquid bromine to -7 degrees Celsius. Bromine is group 7. And even if you forget, you must remember, every element whose name ends in INE or GEN, Gen and in, diatomic. It doesn't matter whether it's solid, liquid, or gas. So long as it's group 7, it's diatomic. So the answer must be A. Cannot be B, C, or D because it's diatomic. Okay, moving backwards again. Okay, let's just go straight back to QA. I think the difficult one was question 6. I know it's difficult because when we had to go through the process of vetting the paper, this is one of the tricks that even chemistry teachers would fall for. Most of you thought, yeah, C and D actually can one. Aluminum and lead, don't they both form a white precipitate that is insoluble in excess ammonia? Right? But you didn't realize the trick, which is the first part. I've told you that question 6, P and Q are solutions. If they are solutions, means they are already soluble in water. So now you look, Q, can Q be lead-2 sulfate? Will lead-2 sulfate form solutions to start with? No, all sulfates are soluble except ClB, right? Calcium, lead, barium. So lead-2 sulfate is insoluble, so it will never form solutions in water. That's why the answer left is C. Please learn some of these tricks well. The trick can even appear in the second word of the question. All right. Now, question 5 was very poorly done. Now, question 5 is actually not from Pure Chem. Question 5 was taken from the 2017 Combined Science Chem paper. And this one really tests whether you know your stuff. When the moist red litmus paper remains red, when litmus paper doesn't change color, it does not mean it is acidic. You don't know, right? It remains red doesn't mean anything, you know. You really got to test with blue litmus paper. See if the blue litmus paper turn red. If there's no change to color, it doesn't mean it's acidic. For all you know, maybe there is no gas at all. Right? So A is definitely wrong. A is an attractive answer, but it's wrong. Maybe there's no gas at all. That's why the litmus paper remains the same color. So if A is wrong, what's the best answer? Obviously D, right? If the solid W was ammonium chloride and you heat it with sodium hydroxide, if it's ammonium chloride plus sodium hydroxide, it should give you ammonia gas, which means the moist red litmus paper should turn blue. The fact that it didn't turn blue means solid W cannot be ammonium chloride because it doesn't produce any ammonia gas in this reaction. So the answer is D. Okay, so this is one of the very tricky combined science MCQs. Okay, and with that, I think I've gone through most of the tricky questions in this paper. Now, for the remainder of the time, we have about 10 more minutes, but I don't think I'll take 10 minutes. How do you do better at MCQs? One, practice. Because when you practice, you actually learn all these tricks, all the main concepts or pitfalls that you might fall for. Two, after practicing, it's also important to get content. No point doing the questions, but you actually don't know the chapters well. And that's where revision comes in. You need to spend this December holidays revising the content for every single chapter and also doing the MCQ revision sets, which will allow you time and practice. Thirdly, generally, you will remember questions that you have scored wrongly. Meaning, as you do the MCQ revision set, you are bound to make mistakes, and that's fine. Embrace those mistakes and ask, why is it wrong? You need to ask me why it's wrong, so that I can explain to you that, oh, it's wrong because da, 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 da. Then you'll remember it better. The last thing I want is for you guys to avoid doing the MCQs because they are so hard. If you look at the MCQs I've given you, I've not just chosen difficult questions. I've not deliberately chosen questions from certain schools. This is a flavor of the MCQ set by all schools in Singapore for pure chemistry. That's why if you do the practice, you will realize that, oh, this is the standard I need to get to. And to get there, I need to practice. I need to accept sometimes it's okay to make a mistake and learn from it. Okay? So that is the spirit I want you to have. All right? So that concludes going through the papers. If you have any questions regarding the papers, not sure about the solutions, please feel free to approach me. All right? Either via WhatsApp or you could arrange a session to go through Zoom with me again. Okay, if not, I shall stop the recording here. Thank you.